What if the universe is hiding most of itself from you on purpose? Not in a spooky, sci-fi way, in a quiet, mathematical way. What if reality is built so that you only ever see the tiny, safe, survivable slice, and the rest is effectively invisible, not because it isn't there, but because you weren't selected to notice it? Start with the strange fact that you are standing in a universe that looks oddly tuned for structure. If the early cosmos had expanded a little differently, matter might have thinned out too fast to form galaxies. If it had been a little rougher, everything could have collapsed into black holes early on. Yet here you are, in a universe old enough for stars to forge heavy elements, calm enough for planets to stay in stable orbits, and spacious enough for light to travel and carry information. Then there's your own position. You don't live in the early universe, when radiation dominated and chemistry was nearly impossible. You don't live in the far future, when star formation fades and the cosmos goes cold and dark. You live in an era with lots of long-lived stars, lots of metals, and lots of free energy gradients. In other words, you show up right when the universe is most readable. Zoom in further. You can only see part of the electromagnetic spectrum. Your eyes detect a narrow band, right where the sun happens to emit strongly and where Earth's atmosphere is mostly transparent. Your brain evolved to compress reality into stories and objects, not to track quantum phases or curvature tensors. Even your best instruments are limited. The universe has a horizon. There are regions so far away that light from them will never reach you, not even in infinite time, because space itself expands between you. So you already live inside a filtered reality, a selection on what you can access. And now, the weird part, physics itself seems to agree that most of reality is missing from your direct view. Look at the cosmic inventory. If you add up all the normal stuff, atoms, stars, gas, it's only a small fraction of what the universe appears to contain. Multiple lines of evidence, from galaxy rotation curves to the way galaxies cluster to the patterns in the cosmic microwave background, point to extra gravity. Something massive that doesn't shine, dark matter. And on top of that, the expansion of the universe is accelerating, inferred from distant supernovae and supported by other measurements. Something acting like a repulsive pressure in the equations, dark energy. So you're forced into a bizarre picture. The universe you see, touch, and are made of is a minority component. The dominant stuff doesn't talk to light the way you do. It barely interacts. It's like living in a city where you can only perceive streetlights and painted signs, while the buildings themselves are made of transparent material that only shows up when you measure gravity. And then comes the cosmic selection problem. If most of reality is hidden, how do you know you're not being shown a biased sample? When you observe the cosmos, you don't just look at the universe. You look at the universe from a place where observers can exist. That sounds obvious, but it has teeth. Because observers can exist is not a neutral condition. It carves out a very special set of environments. Stable stars, complex chemistry, low radiation backgrounds, long timescales, regions with enough heavy elements, not too many sterilizing events, not too many close supernovae or gamma ray bursts. It's a filter. Now connect that to another unsettling fact. The laws of physics contain numbers that didn't have to be those numbers, at least as far as we know. The strengths of forces, the masses of particles, the value of the cosmological constant. You can imagine tweaking them, and when theorists do, even slightly, many universes in that imagined space look sterile. No atoms, no long-lived stars, no chemistry beyond hydrogen, no complexity. One parameter is especially haunting: the vacuum energy associated with cosmic acceleration. Quantum field theory, in naive form, suggests a vacuum energy vastly larger than what cosmology observes. The observed value is tiny, but non-zero, small enough to allow galaxies to form before acceleration rips them apart, yet big enough to dominate the universe today. That just right feeling has led some physicists to wonder if it's not a deep principle but a selection effect. You can only find yourself in a universe where it's small enough for structure. And the deeper you go, the stranger the coincidences get. Dark matter seems to provide the gravitational scaffolding for galaxies. Without it, structures grow differently and might struggle to assemble in time. The cosmic microwave background is almost uniform, but not perfectly. Those tiny fluctuations seed the entire cosmic web. Too smooth and nothing clumps. too lumpy, and you get a violent universe of early collapses. Your existence sits on a knife edge between boring emptiness and catastrophic density. Even the fact that you can do cosmology at all depends on timing. You live when the cosmic background is still detectable, when galaxies are still visible, when the universe hasn't expanded so far that evidence of the Big Bang fades beyond observation. In the far future, an astronomer on some surviving island galaxy might infer nothing beyond their local cluster. They would live in a universe that looks static and eternal, even if it is. So the hypothesis forms: maybe the universe isn't fine-tuned in a mystical sense. Maybe it's vast in possibilities, but you only ever wake up in the rare pockets where waking up is possible. And that could make the visible cosmos feel strangely arranged, even if it's just selection. This idea starts innocent, then it escalates. Because if observation is selection, then what you see becomes a kind of cosmic spotlight, not on truth, but on survivable truth. The universe you can study might be the subset that produces beings who can study. And that can create an eerie loop. You measure constants that allow galaxies and life, and you conclude the universe is special, but you were never in the universes where nothing could conclude anything. Now bring in the biggest version of this thought, the possibility of a multiverse, not as a fantasy, but as a consequence some physicists have explored. Eternal inflation, for example, is a class of models where inflation doesn't end everywhere at once, producing many pocket regions with different conditions. In string theory, there's the idea of a vast landscape of possible vacuum states, potentially corresponding to different low-energy physics. None of this is settled. But it's enough to make the selection idea feel less like philosophy and more like an uncomfortable research program. Maybe there are many cosmic realizations, and you are in one that permits you. And then there's a darker implication. If most of reality is hidden, dark matter, dark energy, horizons, maybe the universe you infer is not just incomplete, but systematically incomplete. Maybe the deepest structure is the part you can't access. Maybe what you call laws of physics are the local rules inside a particular cosmic neighborhood, like weather patterns mistaken for climate. At this point, you might feel like you're closing in on a secret. Like the universe is a locked room mystery and you're finding fingerprints, unexplained parameters, missing mass, cosmic acceleration, observer bias. The case builds itself. But then the twist arrives, and it's more sobering than dramatic. Most working cosmologists and particle physicists don't treat the universe is hiding itself from you as an explanation. They treat it as a warning label, because selection effects can mislead you if you use them too early. They can turn ignorance into a kind of answer. The mainstream view is simpler. Dark matter and dark energy are names for phenomena, not admissions of cosmic concealment. Dark matter could be a new particle or set of particles that interact weakly with light, WIMPs, axions, or something else entirely. Experiments like LUX-ZEPLIN, XENONnT, and others have been searching, and so far they haven't found a definitive signal. That doesn't prove dark matter is unseeable. It means the interaction, if it exists, is subtle, or the model is wrong. Dark energy might be the cosmological constant, a real term in Einstein's equations, or it might be some slowly evolving field, or it might indicate we misunderstand gravity on the largest scales. Many researchers prefer to exhaust these options before jumping to selection arguments because selection doesn't produce precise, testable predictions easily. And about fine-tuning, some apparent tuning might be less fragile than it looks. Complex systems can have broad, stable regions. Life might adapt to a wider range of conditions than our Earth-centric intuition suggests. Some parameters we call fundamental might be related by deeper physics we haven't discovered yet, making the space of possibilities smaller than we imagine. Even the famous cosmological constant problem is tangled in unknowns. The naive vacuum energy estimate is not a clean prediction. It's a calculation inside frameworks that may be incomplete. So the mismatch is real and famous, but what it implies is not straightforward. So the story shifts. The same facts that felt like a secret message, hidden mass, accelerated expansion, survivable timing, can also be read as normal science in progress. Unsolved, yes, but not necessarily cosmic selection. And yet, the alternative explanation doesn't simply disappear. Because the mainstream explanation has its own uncomfortable gaps. Dark matter has strong evidence through gravity, but its particle nature remains unknown. Dark energy fits the data well as a constant, but why that value? Why not zero? Why not enormous? Modified gravity models can mimic some effects but struggle with others. The multiverse is hard to test directly. And selection effects, while slippery, are undeniably real in principle. You cannot observe from nowhere. You always observe from somewhere that can produce an observer. So you end up in a genuine intellectual gray zone. If you lean too hard on selection, you risk turning physics into a story that can't be falsified. It's this way because otherwise we wouldn't be here. That can become a cosmic shrug. If you reject selection entirely, you risk forgetting that your very ability to ask questions comes with built-in bias. You might search for deep necessity where there is only conditional existence. You might demand that the universe be optimized for explanation when it might be optimized for nothing at all. Maybe the universe isn't hiding most of itself from you. Maybe it's simply bigger than your senses and stranger than your instruments and indifferent to your need for closure. Or maybe the fact that you can do physics at all is not a guarantee of comprehension, but a temporary alignment. A brief era where the cosmos leaves readable traces and a brief species capable of reading them. You live inside a thin layer of visibility, surrounded by darkness you can only infer. And the more you learn, the more you realize that seeing has never been the same as knowing. In the end, the cosmic selection problem isn't just about whether the universe is tuned or whether there are many universes. It's about a quieter possibility, that the universe you can observe is the universe that allows observation, and that the deepest truths might sit just beyond the conditions that let you ask for them. And if that's the case, then the most unsettling thought is not that reality is hidden. It's that you might be living in the part of reality that can afford to be seen.